really this is really the output of some conversations with Joe Ripperger at the at the Risk and Crisis Management program at OU, and Joe and I have shared and continue to share graduate students working on we're trying to develop a cadre of people who are both competent on the physical science and on the social science that can hopefully provide us with some benefits as we go forward into doing things. And we have some. Let's see. There we go. Okay, and I'm going to really talk about this from the context of U.S. tornado forecasting, in large part because it's what I know the most about. But it's also I think the tornado forecasting problem provides some really interesting things that we can do. Some of the products that we put out have gone back to 1953 is when we started forecasting tornadoes in the U.S. And most of the broad outlines of the different products I'll talk about today have actually been going on since the early 1970s at least. And so we have a long history. The products get tweaked fairly often. We add the time that we can do things, but that the general outlines of the products start back for about 50 years. And I think that's one of the issues we deal with is the fact we have this long history with how things work. The forecasts really begin up to a week in advance. There is some stuff with the sub-seasonal forecasting, but it's not really very far advanced along. And as we go longer and as we go closer to the time, we get increasing spatial and temporal specificity. And at the long range, the forecasts are regularly scheduled. They'll come out at the same time on a daily basis. And then they're event-driven at the short time scales. So by the time we get down to the warnings, they're purely event-driven, although there are some issues with their timing. All of our tornado warnings end at multiples of 15 minutes after the hour in response to the needs of the media. And so that ends up having some effects on how things are. So the largest scale product we put out is the Convective Outlook. It has both a probabilistic description in terms of the expected aerial coverage. So this is these probabilities would be considered as the probability of an event occurring basically within 40 kilometers or 45 kilometers of any location in the point, and then the hatched area there indicates that there's a probability of a strong tornado occurring. There's also categorical descriptions of these that go along that are based on the probabilities, and there's text that goes with this that go through all of the meteorological uncertainties, all the expected things that happen. And on high-end days, the days we expect a lot of things to happen, there's actually a public severe outlook issue that looks like the Convective Outlook, but it's intended as a more layman's description of what's going on. The Convective Outlooks, when I began in the field a few decades ago, carried as a header above them for internal government use only. And so they were intended for people who are making decisions on the emergency management level, but they're now publicly available. And that's also another struggle we have, is the fact that these products are now can be seen easily on the web, and how much interpretability we want for different levels of users. And that sort of sets the stage for what's going on. And then the next stage is the Tornado Watch. And this is now zooming. This is all these products are from the same, that I'm going to show at the beginning, are from the same day. And the individual and the sort of the large red odd-shaped area is the watch. Individual counties in the U.S., which will become important down the road, and where a lot of our emergency management facilities are located, are the smaller red triangles or red outlines. And then this is actually with the initial radar coverage for storms on that day. And this was we refer to as a particularly dangerous situation tornado watch, which is the highest in product we can put out. There are the PDS tornado watches, regular tornado watches, severe thunderstorm watches. And these are issued usually about 30 minutes before they become effective. The size of this is roughly a few hundred kilometers on a side, and they're valid. This one's actually valid for a very long time. It was valid for 9 hours. Most of them are more like 6 to 8 hours in duration. We experimented with a product in some of our experimental forecasting, where we basically put out a product that said you were likely to be in a watch later on this evening, that was intended for emergency managers and for broadcasters, and we asked them about how that would affect the decisions that they made. In fact, we found that lots of them that would impact how they were planning to staff the rest of their workday. If they knew that the threat was going to be overnight, or in the middle of the afternoon that had impacts on how they would actually begin to work the rest of their days. But the tornado watch has been around since the word watch became to be used for this product, and after the Palm Sunday tornadoes of 1965 as intending to be as a communication guideline. But it contains some probabilistic information in it, but basically says yes or no, you're inside of the watch at this time scale for that time period. And we intend this as a product that's supposed to be saying you should be weather aware for the rest of this time period, and at least know what you're going to be doing if you need to take further action. And then the highest resolution product we currently put out is a tornado warning, and that is the red polygon here that's shown. Tornado tracks that actually occurred on this, or tornado reports that occurred on this day with this warning, are shown as the little icons that we have here. And this is again the initial radar at the beginning of this warning time. This is again from the same day, and this was produced a relatively long track violent tornado for this day. This was back from last April, and you'll note that while some of these things are nice, look like they're related to the perhaps to the storm approaching, we also see issues that clearly we're still using the political boundaries of the counties as the edges of it. And in fact, actually down here on the bottom left, what's going on, this odd shape at the bottom left, is actually the fact that we're now getting into a new Weather Service forecast office area, and so the warning cuts off at the edge of the forecast area. And again, just like the watch, you're either in or you're out of the product. And at this point, we expect people to be taking action. As part of the experimental forecasting process, though, there are techniques being worked on that essentially provide information that kind of looks like a warning and for which a warning might be derived. This is the probabilistic hazard information. It's reproduced within some of the experiments we do, in which we can produce maps of probability associated with a storm, a time history of what's the confidence that a tornado will occur, and now these are tied to the storm. And you can imagine, and it's at least technologically possible very soon, that we could be updating this probabilistic information every few minutes as new radar information comes in, as new runs from WAFs come in, and we could be producing that on an incredibly short time scale and with incredibly high resolution, down to on the order of kilometers of different forecast information for different people. And one of the big questions that I think that the questions we get out of this, that came out of this, as Joe and I have talked through a lot of these issues, are at every one of those stages there's uncertainty involved in making the decision about, do I put the forecast out? Where do I put it out? How confident was I? How does that impact down the road decision makers who may not be aware of the uncertainty that exists at all the levels above them? How can we actually express that information on these really short time and space scales? That's a real challenge, is how do we tell people, how can we get decision makers something that they can use? And we have lots of users that, because of legal requirements, still have requirements for the old legacy products, the watch and the warnings. How do we actually create those products that they need for making their decisions? Because many of them, even on high-end weather days, weather is only a small part of their decision-making process. They have to worry about their staffing, about what their contingency plans are and other plannings, and they aren't going to be checking necessarily for updates very often. So they still need those legacy products that may actually trigger some of their other activities. And then for us in particular, with the tornado situation and the tornado system forecasting in the U.S., is what's the impact of the understanding of our current system by decision makers if we make possible changes in the system? We have 50 years. The tornado watches are almost as old as I am. And so that's all I've ever known in the way we do things. And how often do I have a fundamental understanding of what the word watch means just by those years of experience? And do we lose people who have that understanding as we change things? And probably the single biggest question, we could actually imagine putting together two separate, we could imagine, if we think back to these two products, we could have this incredibly rapidly changing forecast information where we're updating every few minutes and every few kilometers, versus this very static yes or no, you're in. These two extreme events. How can we actually measure or before we do anything in terms of changing things, how can we actually tell which system's better? Have we produced overall value by changing the system, by producing the system? We don't. We have a real issue ethically with essentially implementing a new system, or doing something that we might have with the medical community, where let's put some of the people on a placebo with the old system, and some people receive the new forecast information while they're actually being essentially receiving the treatment for the ailment, which is the weather threat. Is there a way we can actually determine that those changes in the system will do that? Because I don't think we can really do that in a real-time situation. And so those are the questions that we're really are left with, is how can we actually design a system that adds value across places for the range of users, knowing that our users have lots of different needs, knowing that they have one of the things, again, I mentioned that I find the tornado warning problem attractive, and response problem is that it's decision making under uncertainty with great time pressure and consequences for making wrong decisions. If in the hurricane world, I wait 10 more minutes to make my decision about am I evacuating or not, all that's really done to me is I'm further back in the line of vehicles leaving. Whereas in the tornado warning world, if I wait 10 more minutes to make a decision about am I seeking shelter, I might be dead. And so those are really fundamentally different problems. And so I think that's one of the things that, in terms of the way we interact with the judgment and decision-making communities outside of meteorology, that I think those are things that we can actually provide a very attractive problem that they're interested in lots of other communities like medical or police officer responses to events. I think we can really provide some help and learn some things from them. But I think really for me, the top and the bottom questions are the biggest questions. How do we understand how uncertainty propagates, and how can we tell that a system, if we change things, will actually produce overall greater value? And I'll close with that and let us move on.
Great, thanks, Harald.